Hello, Mr. Collier here. This is Lab 23.1 and it is about simple harmonic motion. Today we're going to be looking at different variables and how they affect the period of a pendulum. That is the amount of time it takes the pendulum to swing back and forth. In this lab, you're going to always have the pendulum apparatus attached to the very top hole. The photogate will move, but for the most part it's going to be at hole number 13 with a single black bolt holding it there. The pendulum string can change length, and I'll show you more about that when we actually start taking some data. When the pendulum swings, it goes back and forth through the photogate multiple times. And what the photogate starts to do is figure out how long it took to go through twice, 1, 2, and eventually turns that into a period. On the data collector, we're going to use a new mode. You're going to hit the P for period, and when you release the bob, as it goes through a few times, it will start to get a period on the screen. So for our first set of trials, we're going to be manipulating the mass. To do this, I'm going to take the washers and I'm just going to slide them out of the way. I'm going to pull it back to 30 degrees unless the instructions tell me otherwise. And I'm going to let it go through, say, 6 times. Here's the period. For the second trial, we've increased to 4 washers. Again, I'm going to pull it back to 30 degrees and let it go. There's the period with 4 washers. And for my third trial, I'm going to do 8 washers for the maximum amount of mass, pulling it back to 30 degrees and letting it go. Here's the period with 8 washers. So the next variable we're going to manipulate is the amplitude, how far we pull it back. For our first trial, we're going to pull it back 10 degrees, so it's not swinging very far at all. Here's the period when it's pulled back 10 degrees. For the next trial, we're going to pull it back 20 degrees. Here's the period when I pulled it back 20 degrees. And for the final trial, we're going to pull it back 30 degrees. Here's the period with 30 degrees release. And again, I'm noticing, just looking at my data, that there hasn't been much variance between the 3 different release angles. For the final set of trials, we're going to manipulate the string length. We're going to start exactly where it is with a short string, the photogate at hole 13, and then we're going to move the photogates. Here's the period with the string 20 centimeters long. For the second trial, the string is now 40 centimeters long. We're still pulling it back to 30 degrees, and we are still having 8 washers on it. Here's the period with the string length at 40 centimeters. For the final trial, we're going to set the string at 60 centimeters long, so the photogate is all the way down at hole 1. Still pulling it back 30 degrees and letting her fly. Here's the period when the string is 80 centimeters long. Your calculations are very simple. To figure out the frequency, we take the period that we got from the photogate and just do 1 divided by that period. In other words, take the inverse, and you'll get the frequency. What you should find in your data is that we have almost the same number all the way down until we start playing with the string length. That was the big thing that affected the period of the pendulum. Now you've got a few questions here. Should be simple to answer. A couple graphs with just 3 data points each. And for a bonus, you're going to look at how you might use a pendulum like this to set up a clock.